Earth is barreling through a cosmic shooting gallery. Every day, thousands of space rocks streak past us. Most are harmless, but others have the potential to obliterate an entire city or end human civilization as we know it. And up until now, we've been mostly flying blind through this galactic minefield. We know that we don't know where the majority of these rocks actually are. But that all changes right now. There is a powerful new tool in play. And when scientists turned it on for the first time in June 2025, it found 2,000 new asteroids in 1 week. 2,000 potential threats to life on Earth that have been with us this entire time, but were never seen before. And that is only the beginning. This is the Vera C. Rubin Observatory. It's a big-ass telescope, but it's unlike any other telescope we've seen before. Located in the Atacama Desert in the northern part of Chile, Rubin sits high above the clouds on a rocky mountaintop, where the air is dry and the skies are among the darkest on Earth. At Rubin's core is a groundbreaking piece of technology, the largest digital camera ever built. It's the size of an SUV and weighs about the same. While the latest iPhone has a 48-megapixel image sensor, Rubin packs 3,200 megapixels, more than 66 times the resolution. It's not just about taking sharp pictures. With that kind of power, Rubin can detect objects so faint and far away that they might not even register in any conventional photo. It's so powerful that theoretically it could see a candle on the surface of the moon. That isn't the point, though. This kind of resolution lets scientists find fast-moving asteroids, spot newborn stars, and detect subtle changes across galaxies. It has a scientific instrument designed to catch the smallest movements in the largest canvas we've ever studied. Now, having a fancy camera is one thing, but this is more about the way you use it. Most telescopes capture a still image of the sky. Think of those amazing pictures you've seen from James Webb and Hubble. They are super zoomed-in telephoto snapshots of the universe that capture all of the fine details. While Rubin is more like a wide-angle panoramic Ultra HD video of the night sky in action. Even though it's based here on Earth, it captures the universe with speed and coverage we've never had before. Every few nights, Rubin scans more than half of the visible sky. So, what it's creating is essentially a time-lapse of the universe. And for scientists, this gives them an entirely new ability to rewind, fast forward, zoom in, and view cosmic events that happen in real time. In its first 10 hours of test observations, spread across 7 nights, it found more than 2,100 previously unknown asteroids. That includes 7 near-Earth objects, meaning they have potential to cross our path at some point. Right now, we know of a little over 1 million asteroids in our cosmic neighborhood. Rubin is projected to find nearly 1 million new objects every year for at least the next 5 years. And Rubin isn't just tracking asteroids. It's also revealing comets, including those from deep space. Its sensitivity allows it to detect faint tails and outgassing, helping scientists study these flying balls of ice. In fact, Rubin is likely to find more comets than any observatory before, complementing discoveries like 3 Atlas, a recent interstellar visitor discovered in July 2025 by the Atlas survey. For those counting, this is only the 3rd interstellar object from outside our solar system ever tracked. Beyond asteroids and stars, Rubin is also searching for something deeper. The invisible scaffolding of the universe, known as dark matter. By measuring how light bends around unseen mass, Rubin will map this invisible material with new precision. And by tracking how galaxies drift apart over time, it will help scientists understand the mysterious force of dark energy that is believed to be driving cosmic expansion. That's actually where the observatory gets its name. Vera Florence Cooper Rubin was an American astronomer whose work on observing galaxy rotation is widely accepted as the first evidence for the existence of dark matter in the universe. She passed away in 2016 at the age of 88. So here's how the telescope works. Its camera uses 6 specialized glass filters that can be rapidly switched out every time a new image is taken. Each filter isolates certain wavelengths of light from infrared to ultraviolet, and then creates layers in the image that would allow scientists to isolate the youngest or the most distant galaxies. The main mirror is a unique fusion of two designs, almost like an upside-down sombrero, measuring 8.4 meters across. It has been polished so finely that its surface is smooth to within 1/50th the thickness of a human hair. Rubin actually has 3 mirrors and 3 corrective lenses that work together to gather, focus, and sharpen every bit of light before it reaches the camera. The observatory uses these special LED lights to constantly recalibrate the mirror alignment and correct for any small variations that might emerge over time. But this camera needs more than just lenses and filters to see what it sees. The image sensor has to be kept incredibly cold to work. We are talking temperatures near -100°C. Without the cryogenic chill, much of the data would be drowned in thermal noise. Despite being so heavy, the telescope is so perfectly balanced, it can be moved by hand. When repositioned, it comes to rest almost instantly with no residual motion. That stability allows Rubin to take sharp images rapidly and repeatedly, which is the key to making these panoramic images. The telescope has to be moved several times each night. All in, this observatory took over 20 years and $700 million to build. It was a global effort led by the U.S. National Science Foundation and the U.S. Department of Energy. And what we're seeing right now is just the beginning of Vera Rubin's first 10-year-long observation, known as the Legacy Survey of Space and Time. And as much as we're worried about tracking asteroids through the solar system, we know that there's also a problem with unknown objects much closer to home. The Jeff Bezos-owned Blue Origin has partnered with a small company called Scout Space to make Earth orbit a safer place using artificial intelligence. This is a new mission that has just been announced to fly on Blue Origin's New Glenn rocket in 2026. It's going to be the first real test of the company's Blue Ring spacecraft, which is a kind of orbital transit system that the company has been developing. Blue Ring would be able to travel between multiple destinations in Earth orbit, and it can carry up to 13 payloads, along with it at one time with a capacity of up to 4 metric tons. So it can be used for deploying different satellites at different altitudes, refueling missions, or even moving existing satellites from one location to another. It can even fly to the Moon or Mars. A Pathfinder version of Blue Ring was tested on the first launch of the New Glenn rocket in January 2025. The test payload was meant to validate the spacecraft's mechanical systems and navigation. So for its first real operation, Blue Ring is going to carry the Scout Space Owl sensor to geostationary orbit over 35,000 kilometers above the Earth. For that high vantage point, Owl is going to use artificial intelligence to detect, track, and characterize objects in orbit, including satellites, debris, and other floating material, either man-made or natural. This is something we call Space Domain Awareness, or SDA, and it becomes much more important with the more stuff we launch into orbit. We've only just begun deploying massive constellations of internet satellites. That's along with navigation satellites, observation satellites, and now it looks like missile defense is the next mega constellation that's set to go up. So the idea is that instead of people trying to keep track of all this stuff, we put these autonomous AI sensors up above the whole mess to keep an eye on it, like watchful owls. Speaking of mysterious stuff we put into Earth orbit, the U.S. Space Force is preparing for another launch of their X-37 reusable spaceplane. This would be the 8th flight of the Boeing-manufactured autonomous vehicle. It's scheduled to lift off from Florida on a SpaceX Falcon 9 rocket. That's kind of interesting, because the last time an X-37 flew, it needed a Falcon Heavy launch to reach an extremely high Earth orbit, but it's not going back there this time. What's most interesting about the X-37 is that it spends really long durations in orbit doing mysterious classified operations. Between May 2020 and November 2022, The vehicle spent 908 days in space. We know that it deploys satellites and conducts experiments while it's up there. Typically, these fall under the category of Air Force research and defense innovation. We've been told that payloads on this mission will include a laser communications demonstration and something called a quantum inertial sensor, which seeks to address the challenge of maintaining precise navigation when GPS signals are unavailable or compromised. It is basically the US military exploiting the launch capabilities of SpaceX to maintain a giant advantage over every other nation when it comes to defense infrastructure in Earth orbit, which makes sense. No other rocket can launch as fast and as often as Falcon 9. So for the most part, America can do whatever they want in space, and no one else can match them. Although competition is rising, the Chinese actually have their own version of the X-37 spaceplane. It's known as the Shenlong, or Divine Dragon. It launched for the first time in 2020 and returned to land on Earth 2 days later. Then it launched again in 2022 and spent 276 days in orbit. The most recent launch was in December 2023, with a return in September 2024. As little as we know about the Boeing X-37, we know even less about the Shenlong, or what exactly the Chinese are using it for. Theories range from experimenting with hypersonic missile technology to basically just copying the Americans for the sake of copying the Americans just to show that they can.